Started. Welcome everyone to NASEO's webinar on hydrogen safety. We're really excited to hear from Nick Barilo, who is the director for the Center of Hydrogen Safety. But before we get started, a few housekeeping items. We will have time for Q&A after Nick's presentation, so feel free to type questions in the Q&A box as we go, or you can save them towards the end. And then this webinar is being recorded, so we'll send out the YouTube link in the next few days, so keep an eye out for that. Also wanted to provide a brief background on NASEO's hydrogen work and kind of how this safety presentation fits into NASEO's broader support for hydrogen. So aside from NASEO's Hydrogen State Working Group, which Grace Lowe from NASEO leads, NASEO is also working on a project to develop a framework for states on the siting, permitting, and safety considerations for hydrogen fueling infrastructure. To kick off this project, NASEO hosted a workshop in Baton Rouge, Louisiana back in September that convened a variety of key stakeholders to discuss hydrogen activity in Louisiana, some pressing questions and concerns around siting, permitting, and then, of course, safety. So one of the key takeaways was that many community members, authorities having jurisdiction, and kind of other key players in the hydrogen space that would be involved in some of these siting, permitting, and overall planning for hydrogen fueling infrastructure could benefit from additional education on some of these safety considerations and protocols to deploy hydrogen fueling infrastructure safely, and also respond to some emergencies involving hydrogen safety as well. So we thought it would be great to hear from our friends at Center for Hydrogen Safety on a hydrogen safety one-on-one to kind of provide that base level of understanding. So with that, I'll hand it over to Nick and I'll tee up your slides for you.
I'll just do the slides on my end.
Oh,
That's
okay,
good.
perfect.
Yeah. Okay, give me a chance here to get myself started. Let me know if you guys can see that.
Looks good. Yep.
Okay. All right. Well, greetings, everyone. My name is Nick Barilo. I'm the Executive Director of the Center for Hydrogen Safety, and I also manage the Hydrogen Safety Program at the Pacific Northwest National Lab. It's sort of a joint role. My background is fire protection engineering. More than 40 years of doing that and been involved with a lot of work on with the Department of Energy, as well as lots of folks across the national and international front to promote hydrogen's rollout and ensuring safety. All right, who is CHS? For those of you who don't know, it's a global nonprofit. Really, our goal is a world committed to hydrogen safety, and we do that by providing guidance, collaborative forums, educational materials, everything to help us realize those transformative benefits of hydrogen. You can see some of the areas where we will serve and foster, but we also are really rich in resources and strong in collaboration focused on impact. And you can see some of those areas there, and I'll talk about some of those as we move through the presentation today. Just wanted to give you a look at who some of our members are. This is the recent update of our membership. You know, what always strikes me when I see this is it's more than just a list of company names. Really, it's a list of those that are interested in hydrogen safety and want to be seen as leaders in the space. So lots of companies you probably can recognize the names on. These folks have all been a part of what we're doing. Some of them more than others, but certainly all of them, as well as the executive members you can see at the top, have been very, very involved in what we're doing as well. So then we have a lot of strategic partners down there on the bottom, and that list continues to grow as well. Okay, what we'll cover today. So we're going to talk a little bit about fueling stations and some foundational knowledge that might be helpful for understanding how to go about putting in a hydrogen fueling station from a safety perspective. We'll talk about the hazards of hydrogen safety first, and then we'll go into some of the strategies to address these hazards. I'll share a couple lessons learned, and then we'll go into some resources, tools, and training materials. Okay, so while everybody may understand this question, I'm gonna frame it up anyway. Why safety? We get a lot of folks that may not have the same level of understanding towards safety as we do. And so we like to sort of set the foundation and the level the playing field a little bit. So number one, really to protect workers and communities. We want to make sure that it's built safely, that the hydrogen infrastructure does not put anybody in harm's way. It's also for building public confidence, because if we don't do this well, if we have start having incidents and failures, then it's going to reflect poorly on the industry as a whole, not just the one station or facility that it's being put into. Uh, Making sure we do good public use of or good beneficial use of public funds, that's critical as well. So if we don't, again, if we don't mind safety, we can end up not getting the benefit of those fundings. Enable the clean energy deployment and then support regulatory compliance. So, uh, if you come across anyone that really doesn't have those good perspectives, always good to send them our way. We'll be happy to chat with them on those topics. All right. Well, hydrogen's not new. Been around for about a century or a little more. You can see some of the numbers here. The Haber-Bosch process was started in 1913. That was to get to ammonia industrial use. We're up near 100 tons per year, 100 million tons per year right now. And last year and a half ago, we did a poll of the American public. So we wanted to find out what were their thoughts on hydrogen, and where do they see safety relative to hydrogen. This is what we end up, just some of the stats. I don't want to go into them all, but there's fairly low awareness. That shouldn't be a surprise to anyone. I think the 62% being open to hydrogen was really encouraging, as well as the 79% wanting to know more. I think the most surprising number that we saw was the 2.4%. We talk about hydrogen, and you tend to hear a lot framed around, well, it's the Hindenburg and it's not safe. But really, what we saw more of was folks centering around the chemical use of hydrogen. So they think of like H2O and those sort of things. So I wanted to say most people need the basics first, and that's something important in your jurisdictions and areas, your states. Trust grows when safety is clear and interest rises with better understanding. So those things should help you understand some of the pathways to get to public support. I do want to highlight that we're not starting from ground zero, but it is new territory. The applications differ fundamentally from what was experienced in industry for that last century. So, and all the more important reason why we need to take safety seriously. Okay, let's look at some of hydrogen's unique hazards. Things like combustion should be obvious. Everybody's aware of this. Very, very flammable range, extreme flammable range for hydrogen. It also has some ability to give off some really excessive pressures when it combusts, and we'll talk about that in a minute. In storage, it's high pressure storage. Now, this isn't in many ways unique to hydrogen high pressure storage, but the thing that maybe differs a little bit is that um, hydrogen, when it's released, tends to increase in temperature, and it also can form jet fires. But if the jet fires don't occur, then it also can form clouds. And so those are the things that make it a little bit more um, important to understand and consider. Embrittlement's another one. So hydrogen can embrittle materials, welds, steels, pressure components. The harder the steel, the worse it is. Asphyxiation, but this is not really anything different than a common asphyxiant. Cryogenics in liquid form, the cryogenics, things like cryogenic burns, condensation of oxygen. So that could be a real problem if there's exposed piping or insulation is torn off. And it undergoes a rapid phase change. So that oxygen enrichment, both from the condensation but also from electrolyzers, is a bit of an important point to highlight here, because um, if you get into larger electrolyzers, the oxygen hazard actually starts to become much worse than the hydrogen hazard. So really important to consider that if you're looking at those large electrolyzer facilities. Okay, let's compare some properties and see how hydrogen is different. So I mentioned the flammability range. You can see the various methane, propane, hydrogen, both in air and oxygen. Now, we talk about this range being extreme, and it is. I think the important part, though, is the left side of those bars, because that's where you're most likely to get into trouble, is the lower flammable limit. And you'll notice that a lot of those flammable limits are very similar to hydrogen, methane, propane, and as well as hydrogen. Propane actually a little bit less concentration to be a problem as well. The other thing about hydrogen is in the under the 10% number, you tend to get flash fires with hydrogen. You don't tend to see those pressure waves developing. There's no downward movement of the flame through the hydrogen mixture. And so it doesn't tend to be as damaging. Up and around 10% and higher is start to when you start to see those pressures being developed. And you see that burning velocity down there on the bottom. So the burning velocity is about almost an order of magnitude greater than methane and hexane. And the higher the burning velocity, more likely it is to generate explosive overpressures when confined or in congested areas. There was an incident that occurred back in 2019. It was a steam methane reformation facility, and they were using it to taking that into hydrogen, and then they were storing the hydrogen and then taking it to their customers. There was an explosion occurred. The first thought was, well, that's a natural gas explosion. Upon further review, the fingerprints were hydrogen because of the pressure wave and the number of homes that were damaged. There was about 62 homes that were damaged. Now, most of that damage was cracked glass, a broken glass, things like that. Not significantly after the first row of houses. The first house had a little bit damage; some doors were knocked off and things like that, but nobody was injured in the incident. The graph there up on the top right, the impact of vapor density. It's an interesting one because you can see that hydrogen is very buoyant, wants to move up and away. That really occurs after the pressure effects are gone. So with that very high pressure, if it's leaking horizontally, it's going to do that for quite a distance before it starts moving in that buoyant curve upward and outward. But the thing to compare versus some of the other fuels, especially in an open environment, is that where gasoline is going to sit on the ground, the vapor is going to hang on the ground until someone cleans it up or it volatilizes or is burned. Hydrogen is going to just move up and away and wants to get out of there and move out. Natural gas will sort of meander around, and propane about the same. The other thing to think about, though, when you're looking at this vapor density is that in enclosed spaces, that hydrogen is going to tend to accumulate at the roof, and thus we need to think about how we ventilate. Lest you think hydrogen is something really, really bad, and so I like to show this slide because we've grown comfortable, if not complacent, over most of the fuels that we use these days. So things like gasoline, natural gas, you can see some of the average number of fires at a given time frame, number of deaths, number of injuries, property loss, et cetera. So really the key here is going to be making sure that we do the right things to keep the number of incidents down, but also to recognize that it's going to take some time for folks to acclimate and get more comfortable with hydrogen as a fuel. So some engineering principles that govern when you think about hydrogen should be obvious. And this is really true for almost any flammable gas. Just keep hydrogen in its pipe. The system integrity, really that's the key barrier. Try to minimize the number of leak paths, fittings, things like that. And then monitoring for it. If leaks occur, dilute it quickly, but making sure that you understand when leaks are occurring as much as possible. There's lots of different ways to do that. Sometimes you could do it by monitoring the pressures and flows in the pipe. Other times you need spot detectors outside. Making sure that the ventilation is such that you have low, in an enclosed space, such that you have low inlet, high outlet, so that as that hydrogen moves upward, it can have an exit path. And making sure that you don't trap any locations as well. Shutting off the gas at the source. Typically, you would tie your detection in, or whether it be emergency shutoff switches or manual detection or automatic detection. You would want to shut these off back at the source, not near where it's being used, because that gives you your best chance to make sure you continue in a safe environment. Fail-safe hydrogen-rated equipment. We've been in locations where we've done walkthroughs and seen that some of that equipment wasn't rated very well for hydrogen. A nuance here is, for those of you that are familiar with some of the electrical requirements, so Group B is what it needs to be rated for, that electrical equipment, not Group C or D. C or D are meant for other fuels. Group B will handle those other fuels, but we've been in locations where they've had Group D equipment in there, and it just it doesn't provide protection for the hydrogen. So what are the risks at some of the fueling stations? Well, leak and release events, those are, let me say that while small leaks can accumulate in confined spaces, for the most part, small leaks, especially with the outdoor equipment, tend to be very minor and insignificant. You get this weeping effect as you go through thermal changes on the system. So especially those that have significant changes in your temperatures year round, you'll see that the pipe expand and contract, and when it does that, it opens up a little bit of a leak point. And usually when that occurs, it's not significant. It's not a significant hazard or something that really warrants shutting the station down. It really is a maintenance issue, and they go in routinely and check on those sort of things. Because there's high pressure storage, it's just something that we need to be aware of. You're talking in the 5 to 10,000 psi range. And so the materials need to be the right selection for materials. I'll show you why that's important in a moment, along with properly designed pressure relief and doing inspections and that sort of thing. Cryogenic liquids. So cryogenic liquids have their own complexity. They will, when they leak, they will turn quickly to a gas. That gas will hang towards the ground for a little bit while that cool gas starts to warm up and then move up and away. So, it's one of those things that we need to maintain the vacuums, we need to maintain the insulation materials, et cetera. There was an incident that occurred at a university in Washington State that they had a doer inside of a lab. They didn't adequately assess their hazards. So what happened was a squirrel hit a transformer, and goodbye squirrel, but also goodbye power for the building. And so when that happened, they not only lost that ability to keep it in a liquid form as it started to warm up, the door started to stop doing what it was doing and started warming up. But they also had tied into the ventilation that was on the same circuit. So they lost their ventilation at the same time. And then a third thing happened, and they had a valve in there that failed. And so they were getting hydrogen actually being distributed into the lab space. Fortunately, no one was hurt and there was no fire. So very, very fortunate. They've since plumbed the ventilation out directly outside through a high point through the roof. Fire and explosion, those can occur. And then public risk interfaces, public interface risks. This is really something that's much different now than what we've been used to. In the industrial setting, it's folks that have great experience, done it for a really long time. They understand how to do those things well. We're now having the public interface, and you say, well, that shouldn't be a problem because the dispenser's set up to do its thing. That's true, but we've seen instances where somebody has brought their own homemade tank in and tried to fill it with hydrogen. It's extremely dangerous, and those are the kind of things we want to avoid. Okay, so a couple of incidents that occurred, and these are both fueling station related. One was at a bus fueling station. There was about 300 kilograms of hydrogen that was released over 2.5 hours. The cause of this was an incompatible pressure relief device. So that we talked about making sure your materials are compatible with hydrogen, and this is one area they didn't do a good job on that. They ended up having that device fail, it cracked and leaked. There were no injuries, there was only minor equipment damage, but the fire department was not well trained on the hazard, and so they evacuated out about a mile in businesses and homes, and it was really just venting out the vent pipe. So this is one of those areas that you'll see really identifies the need for good first responder training. So improving that emergency communications procedures, there was a lot of miscommunication, no communication. So that was a big part of what they learned as well. The second one was a fueling station tank leak and fire and explosion. This occurred in Norway back in 2019. It was a high pressure storage tank that leaked and had a jet fire, probably an open air deflagration before they had that jet fire. The root cause was an assembly error. The inner bolts on the sealing and plug were not adequately torqued, and that allowed it to flow out and have the event occur. No injuries, minor station damage. Airbags were activated on nearby vehicles, and really it was the assembly procedures and witnessing verification, that sort of thing. What I want to point out to you on both these incidents, and this is not uncommon when we see both in hydrogen and other industries, that human error can be a really big part of what's happening. And I think that's what you're seeing here is human error in both of these instances. So strong safety culture and encouraging good safety best practices is really important to make sure that we keep these to a minimum. Okay, I wanted to point out a hidden infrastructure vulnerability. So we are seeing here on the top left on this figure is a single source. So you have one vendor supplying hydrogen to the fueling stations. Some sort of an incident occurs, it causes a disruption. Now, with that incident occurring, they have to go back, they have to look at why it occurred, is it going to happen in other locations, et cetera. There have now been at least three events that have occurred in the last 7 years, or 8 years it is now, in which the infrastructure for an entire or half of California went down because of an incident that occurred and stayed down for upwards of 6 months. And so, something to think about if you're getting into fueling stations is multiple sources and maybe multiple technologies. It'll help you with reliability. So providing more than one vendor and maybe the way they get to that fuel is different as well. So they're not relying on one method to do that. So I did want to point this out because you've seen, certainly if you've been paying attention to the news in California right now, a lot of the drivers can't get fuel and are pretty upset. Some are taking up lawsuits, et cetera. So best way to do this is build in redundancy in both the technology and the vendors. Okay, so planning for success with a project. So let me hit on a few things that we've learned over the years. The panel's been doing a lot of work now since 2003. So providing an emphasis for safety for hydrogen projects. If you are going to fund projects in your state, I would suggest that you establish minimum safety criteria, require a safety plan, emphasize the need for a strong safety culture. Really, really important to minimize those number of incidents. And since you're in control of the dollars, so to speak, that it gives you that ability to do that in a way that's meaningful and people will listen to. I've often heard it said that with safety culture, people will go to what they're rewarded for. And I think that's really true. And so if they're not rewarded for bad behavior, they're rewarded for good behavior, then they tend to do that good behavior. Preparing the approval authorities, so education opportunities for the permitting officials and others that are involved, other stakeholders, connecting them with some resources. I'll give you some of those later. Training your first responders, really important part. And you saw at least one reason why that was the case. Community outreach, we found that to be extremely important. Answering questions, getting in there, understanding what the concerns are will help more of a public acceptance, and then engaging with some outside resources to help. Okay, on the regulatory standpoint, these are just a few. I just wanted to point out a few areas that to think about. Most states are under the ICC codes, which means the International Fire Code and International Building Code. Those for stations or repair facilities pull in NFPA 2. It's directly required, not necessarily for all applications with hydrogen, though, something to keep in mind. And NFPA 2, the Hydrogen Technologies Code, has been around now for a decade and a half, and it's a primary US model code covering hydrogen fueling at stations and siting and those sort of things. And then you start to get down to the standards level. That's things like ASME and CGA for how to do those things. And then for the fueling, J2601 is a fueling protocol that governs. And so you see how these tiers go and covering different parts. I also want to stress that codes should be the minimum. They should be the floor, not the ceiling. Best site safety practices are encouraged and should be promoted, especially where the technology is fairly new and the codes are playing catch up. Okay, I'm going to introduce you to some resources now. They go from everything from public and free to being a part of the CHS membership. Things like H2 Tools Online, I'll talk about that in a second. There are webinars. These webinars are free the day of the webinar, so I encourage you to be a part of that whenever you can. We have some training that's online. Some of it is free. All our first responder training is free. Others are at behind a paywall, except for laboratories. That one is free as well. Expert reviews. So the safety panel, who I mentioned, I'll talk a little more about in a second. They are available. They are supporting the state of California and the Center for Hydrogen Safety and the Department of Energy in performing reviews right now. And then certainly being a part of the center helps you to connect with resources and people in this field. So the Hydrogen Tools Portal, it's about 3,500 pages. It's got best safety practices, a library of more than 100 best safety practices. The fall of this year, we'll introduce a new set of best safety practices on blending hydrogen into natural gas piping systems. So that's of some interest. We have two lessons learned databases. Well, we have two incident databases, let me call it that. One's a lessons learned focus. The other is a sort of a focus on just what happened. Those are both available, and there's over 1,000 records between the two of those. And then we have things like technical guidance reports. The safety panel has just released a white paper on ventilation. Two more white papers are coming out this month for the membership. It's about 6 months to allow the internal members to take a look and make sure there's nothing that would be needing further revision. So those will be available sometime in the fall. That's on delayed ignition, and the other is on recent trailers, trailer configurations and incidents, and what have happened and what have we learned through all those events. So encourage you to go out to H2 Tools. That site is free. So how does CHS help? Well, CHS has a lot of things that can be of assistance. We track incidents. That's one of the areas that is really of interest to our members quite a bit is the incident database. We're giving monthly updates on incidents that we hear about. We're tracking about 30 incidents right now from all over the world. Some of those have fatalities in them. It's a very diverse, a very diverse set of incidents, although I would say buses tend to be pulled out as having a few more than others. We have working groups, and those working groups are to handle current issues. The blending best safety practices coming out of that working group. And then we're going to be looking at codes and standards and geological hydrogen coming up. We do things like safety gap analysis and best practices. We learn from those incidents, and then we try to pivot around what those learnings are. The members are really kept informed on what the incidents are, even if we don't have strong information, as can be understood, because the legal blackout that occurs when an incident occurs, we still have folks that understand the equipment and can speak to that equipment and can give some perspective that helps when thinking of the incident, what might have occurred. Training and competency programs. Workforce is a big part of where we're headed, needing to get that workforce prepared. So whether you're new to hydrogen or in a different work area and are transitioning across, some of these programs and resources can help quite a bit. We have emergency responder resources as well. And then we're really a community, and that's what it's all about, sharing information, coming together. The meetings, the conferences, they're all extremely engaging. We've had 9 conferences around the world, and in all those conferences, we get great positive feedback on folks seeing that it's not a sales pitch, it's not a trade show. These are highly technical events, as well as our webinars. Okay, so some of the training programs, and this is actually one that occurred last fall in the background, but there's things like on the fundamentals, and I'll show you what some of those look like here. So this is our current webinar and e-learning courses, apart from the first responder. The first responder have another set of e-learning courses as well, but you can see it's very diverse. Right now, members are the only ones getting access to those webinars after the day of the event. Again, we give it free the day of, and then we move it behind the member wall after that. And then in things like NFPA2 code training, we have a basic and an advanced, and the advanced is really great to understand some of those issues that are challenging us as we're doing things. We have the ability to get a credential. And we have one credential right now in fundamentals. We're going to be moving towards additional credentials in the future. I mentioned the NFPA2 training, and as I stated before, there's some training for first responders. This is an actual incident that occurred in California you're looking at here. And I want to stress emergency response preparedness, because These guys are facing more and more challenges. The first responders are now, especially in the transportation sector, when they come upon an incident, it's not always clear what fuel is involved. You have batteries, you have hydrogen, certainly compressed natural gas, gasoline, diesel, and the fuels require a response different depending on what it is. And so, well, I'm showing you a picture of this. This was the Diamond Bar incident in California. There was also another incident in California 2 years ago in which it was a CNG vessel, compressed natural gas, but it's very similar and it's set up to hydrogen. It's a high pressure vessel. And fire department responded to that incident. At some point, they started putting water on the tanks, and the tanks ruptured. The temperature activated relief device that did not go off, and 9 firefighters were injured in that event. In another instance with batteries, though, there was an incident that we were aware of that first responders were there. The batteries were thrown across the ground and were off gassing, and they didn't realize they were dealing with some toxic gases being given off by those batteries. So we actually had one fire department say we'd rather deal with hydrogen than we would. That was the department that had the 2 firefighters who got seriously injured. All right, so I want to focus. So this is a little bit involving the safety panel. Here is a picture of the safety panel. This is in Phoenix, Arizona. The folks all on the left there are safety panel members, so give you good perspective and getting some feedback from these folks on this hydrogen installation. So the panel can provide support for state-funded projects. We do this in California right now for the California Energy Commission, as well as many of the transportation-related agencies. So that's a possibility that can be done. There's lots of different ways to do it, and I can certainly answer any questions. But it's bringing that very deep 800 years of experience to bear on projects and ensuring that safety is considered. The panel was actually put together in 2003 to make sure that the rollout of hydrogen would not be adversely impacted by the lack of focus on safety. So it's been evaluating projects ever since, and then we're up to, I think, 715 or 20 projects or reviews over 500 projects. Big on providing, looking at incidents. We have panel members that are paying close attention to the incidents and getting more information. Again, we're putting out white papers and those sort of things as we're able to. Grant condition guidance. We've learned a lot helping in California, and so that's available if you want to have us look at it and say, you might want to consider this for safety or that. And then stakeholder convening. We've had opportunities to talk and be a part of groups and with state officials and doing things for state officials and meeting with others on the stakeholder realm of things. So getting down the wire here, and I'll wrap up in a second, but safety planning essential. It should be obvious by what you've seen and heard. There is a guidance document that is freely available. You could recommend it for your projects. It's been around since 2005, had a lot of road put on its wheels. And in 2025, we updated for process safety management, integrating principles into the guide. So it's very set up to be focusing a little more on the PSM as well as safety culture. I wanted to make you aware of this guide. This is a guide that the Center for Hydrogen Safety and California Hydrogen Business Council put together at the end of last year. It's a great guide. It's not really just meant for California, but it was funded out of California, and that's why it's got the title on it. But it really provides some great information that can be used for those that are stakeholders, for politicians. It really cuts through complexity and gets to here are the risks, and here's how those risks are handled, as well as looking at lots of different applications and what needs to be considered for safety on that front. So that is available off the Hydrogen Tools portal that I mentioned earlier. There's a document section, and this is available in that document section. Also wanted to mention a conference coming up. So if you want to learn more about hydrogen safety, we're going to have our next conference in the US in March. Probably be our best conference yet. We're including training as a part of it. No longer is that going to be a separate activity. These comments are out of our last 2 conferences that we've had. So you could see some great feedback there, and that's just the tip of the iceberg what we get. So love to have you. If you have any more questions or you would like to present, let us know. Love to see you at this conference next year. So what are the next steps? Well, for partnering to get the infrastructure off the ground safely. So engage with us. We're available for technical support. We've got a long history of doing that, and would love to work with you. Require safety best practices and grants, just reiterating that again. And then if you're able, join the CHS network. So the California Energy Commission and NYSERDA are both members of the Center for Hydrogen Safety. So would encourage you on that front as well. Okay, well, I'm conclude with that. There's a QR code there that you can use to see some of our offerings and course catalog. And what do you have for me for questions, Grace?
Wonderful. Thank you so much, Nick. That was a really helpful overview, and thanks for plugging all of those resources and trainings that are out there. Excited to look into those more. Happy to open it up for questions from the audience. I see we have one in the chat already from Stephen asking whether NTSB investigates hydrogen safety incidents or if it would be the fire marshal or someone else.
So both. So, and it depends on the incident. So the recent Colton, California incident, I think, is being investigated by the NTSB. The NTSB investigated the CNG incident that I mentioned earlier that the 9 firefighters were injured on. They didn't investigate the incident in Delaware, Ohio, back a few years back that occurred with a transportation vehicle. So it's a little bit hit and miss, but the really great part is they tend to do thorough investigations. And the fire marshals get involved in most investigations in their jurisdiction in one way or another. Challenge here for all of that is that, especially on the fire marshal side, the state side, is there aren't a lot of great resources for those folks to try and bring into the discussion. And so we've been trying to tell people the safety panel is available, CHS is available. Let us know if you would like some expertise to be a part of those investigations. We'd be happy to do it. Another thing you could put in your grant funding criteria is that investigations will be opened up to the safety panel. So we could keep things confidential, but really can bring some really good expertise to understand why things happen and how to avoid that. And we're seeing problems that tend to permeate across the industry and tend to do what I chatted about earlier, which was the outages because of trying to go back and looking at finding that this problem permeated across a lot of their equipment. So both, but we'd love to help out. If you want to get us involved, let me know.
Great. Thanks, Nick. Thanks, Stephen, for the question. Feel free to keep them coming in the chat, and we'll do our best to get to everyone's questions. In the meantime, I have a few for you, Nick. You mentioned a lot about fueling stations and safety considerations, in particular for those types of hydrogen projects. I'm curious if you could give maybe speak on some of the differences across other types of hydrogen projects or other transport methods and uses, other considerations that states should keep in mind.
Sure. So fueling stations themselves represent some unique challenges because of their locations. They're typically in close to public. It's hard to shoehorn some of those operations in, and there are challenges with doing that. You start thinking about other applications such as electrolyzer facilities, large production facilities, whether it's electrolyzer or steam methane. Those tend to be out beyond the headlights of some of the codes. The codes really weren't meant to address large production facilities. Think of Air Liquide's Las Vegas facility that came online a few years ago, and it was that's not really well addressed by the codes. That's real. Now you're into process safety management space, so there's challenges there. Other transportation, so whether it be buses or trains, we did a review on a train repair facility. That was really interesting because it's the first time that organization in California had a hydrogen train, and what did they need to think about relative to the hazards? So it's not the same type of hazards they've been used to. They've been used to diesel, and they've been used to other and electric, and they're not used to having hydrogen inside their repair garage. And what do they do now? So those are some of the things to think about. And then all across all of the transportation, not only is it the first responders that are at risk, it's also the second responders. So those are the wrecking crews, et cetera, whether it be a passenger vehicle or a medium or heavy duty vehicle. Those represent some different challenges, and we got to be careful about which repair garages get those if they're not careful and don't know what they're doing with the tanks, potentially full hydrogen, and that could be catastrophic. And so those are some of the other challenges as well. And then heavy duty transportation is making its way in, and those carry large amounts, upwards of 100 kilograms of fuel on board. You're seeing more buses as well because the battery buses tend to have some struggle especially in hilly areas, that sort of thing. That they need the hydrogen to extend the range on those. So there's different. I mentioned new electrolyzers. The oxygen hazards can be serious there. So just different uses, different facilities have different challenges. Indoor applications present a much different challenge than outdoor. So those are some things to think about as well, and important to evaluate everyone individually. A lot of times the codes require, especially for fueling stations, they require a hazard analysis to be done. But regardless of the use, whether it's a fueling station or not, a hazard analysis should be done. And it can be done in a manner that's a graded approach, consistent with the complexity of the project.
Got it. That's great advice. And a related question from Renee in the chat. Are there special instructions for hydrogen applications in industrial settings?
So the codes have been around for quite a while for the industrial settings. So NFPA 55 at one time was the primary code from NFPA, and certainly the International Fire Code had some requirements in it as well. So the legacy industrial applications, very well equipped. Doesn't mean that they do everything right all the time, but we've seen some instances of that. But they're much more experienced and understand those issues. Some of the other new application industrial settings are the one that create challenges, whether it's small industry, medium industry, large industry. What we're seeing is safety culture being the key. So you talk about your big air gas companies, and those tend to at least understand, as well as organizations like Shell seem to really understand what safety culture is. Doesn't mean they don't have their problems applying it sometimes, but they really get why it's important and try to work on that. The small and mediums may not understand the value of that, and so maybe cutting corners and taking risks. And so if it's a small industry, startup industry, really important that you work with them to make sure that they're addressing safety, that they understand it, and that the code officials that are permitting them understand it, so that it's given all opportunity to do the things that need to be done to keep it safe.
Great, thanks. And then getting into the permitting a little bit more, you mentioned several codes and standards and kind of how hydrogen fits into those. And just the number of jurisdictions involved in permitting hydrogen safely. I'm curious if you could speak to any challenges or best practices in sort of embedding those codes and standards into the permitting process, and any advice for coordinating across agencies at the state and local level.
Yeah, that's a great question. We've seen quite a bit in this area. So I mentioned the ICC standards apply to many of the states, not all of them, for sure. But there's another nuance in applying the ICC standards. They're not all applied given the latest edition. So we've been in locations where it's been 10, 12, 15 years old, that the standard goes back, that's the one they're following. And that's not going to have the current requirements with hydrogen. It's not going to cover the topic very well. And so that's a bit of a challenge. Certainly as we go forward, that needs to be addressed. The other thing is that jurisdiction to jurisdiction, how they apply those codes and standards can be very hit or miss. Many of you have probably seen some of the announcements about Douglas PUD in Washington State. They were faced with some significant challenges trying to get it approved and permitted because the code official there didn't feel comfortable with it. And so how do we overcome those challenges? How do we help them understand? what's an acceptable level of risk per the code and what the jurisdiction's willing to accept and how that works. Because if we don't, and I think in their case, their program was delayed quite a bit and ended up being hit with some substantial modifications that probably could have been averted if the code officials were a little more engaged with moving forward and understanding how these requirements have come about. So bit of a challenge there, and I think that's at a state level. If your state, the other thing we saw is in um, small jurisdictions, we found that they're less equipped and prepared to handle permitting, don't have the resources. We've seen some that farm that out. They just give it to an organization to cover for them. And in one case, the organization said, hydrogen's just like natural gas. We don't need to worry about it. Very bad assumption. So it varies greatly, and that's where the state may be able to help because the state tends to, at the fire marshal level, maybe equipped with the resources it needs, or so could the state provide the resource to support, or could they be the one? South Carolina for a while, I don't know if they still do it. The state fire marshal was approving all hydrogen installations. They were just handling it out of the state fire marshal's office. So lots of different ways to do that, but getting in front of all this and thinking it all through and getting some training for the permitting officials is really a great idea.
Great. And on that note, I know you mentioned several kind of certificates and training resources that you all have. I'm curious how that intersects with sort of the workforce development pipeline for workers in this industry and what role industry plays. Are there additional opportunities to sort of integrate those trainings and resources into existing workforce development areas or, yeah, any gaps you want to highlight in that space?
Yeah, so I think it's recognized that workforce development is important. There's been some efforts to do that. There was a college in New Mexico that put together a program. They've sort of had to put it on pause because they weren't getting the amount of participation they needed. Same for Washington State, was working forward on some of that. I think so we have worked with some of those organizations to either review their information for safety or to try to integrate some of our material directly into their training. We're doing both right now. H2 Skills is a program supported by the U.S. Department of Energy, and we've been working with those folks to try and get some of the safety materials integrated right in. Also working with local colleges, universities, and technical schools, we can integrate some of the safety pieces in with them. So if you have the desire, let us know on that front. We'll be happy to work with you to see what we can do to get some of that material to where you need it.
That's great. And in terms of industry partners, you mentioned a lot of CHS members who are in the industry and the importance of the culture of safety. But I'm curious what other ways are our industry partners kind of helping support safety in this area, and what partnerships could states look at with industry, or how are you all partnering with industry folks?
Yeah, it's an interesting thought. We've actually, as the need for training resources or new credentials or having facilities that could do training, hands-on training as part of training, there's really an opportunity there for industry to work with organizations like ours as well as others. And we've seen some of that already. I think that's continuing to grow. Certainly helping to support industry can really help support on what knowledge they're gaining from their applications. And so we try to actively do this with our members. What are the challenges you're running into? We put together for the last conference, we had a gathering session to identify what are the things that are needed in pre-normative research as a result of the experience in applied settings. And so these are the kind of things that can really help out. What's working, what's not working, what do you need? Ultimately, at the end of the day, we're here to help everyone, organizations such as yours, as well as those that are doing the work, helping them to get what they need to do this safely. So the door is wide open for all that. We have different partners that are starting to come together with us to develop joint training and to deploy that joint training more broadly. And then we're working internationally with partners as well to bring some training there. We're going to start having more symposiums and things like that as well. And industry participating in some of that is really important. So I think that the industry that focuses on and keeps safety a priority needs to step up and show the others that may not understand it as well why it's important. If I can say any one statement, that would be it.
Great. Well, I wanted to touch a little bit on some of the sort of community engagement, stakeholder engagement side of this, and particularly given the poll that you did and how folks are maybe not as familiar with hydrogen or don't know about the safety risks, and especially for fueling stations when they may be interacting with the equipment more than your typical industrial application. Any strategies that you've seen work well in terms of building trust, educating the public, and addressing some of the misconceptions about hydrogen?
Yeah, I think there's a few things, Grace. I'll start out at the really high level. I heard a few years back in a conference that the industry in locations where the country, or in this case, the state, support the deployment of a technology, that technology will do much better. In those places that don't have active support, it's going to struggle to survive because people just don't trust something new. And if the government's not going to get behind it, then they're like, well, we're not going to get behind it. We don't want to put ourselves out there if the government's not willing to. And so I think some of that occurs in the process. And so um, I think on the other front, it's critical that in meetings, setting up town hall meetings, really important. We've seen the value of those. We've seen the impact of not having those. But even more important than setting those meetings up is having the expertise in the room, whoever it may be. I'm not saying it has to be us, but whoever it may be, that they understand the issues and they're able to talk to those issues and do it in a way that's transparent. I think really critical because sometimes, there's been some efforts that have sort of backfired. I think we've seen some of that in the Northeast. Some of those efforts have backfired because of the approach that was taken. So I think but it's really important to let the public know that they're valid questions. They're not always easy to answer. And sometimes I think we have to do some training on risk. Every day we go in and all of us are taking risk every day and everything we do, driving a car, crossing a street, we're all taking a certain amount of risk. And you're putting gasoline in your car every day or every week. And so there's risk associated with doing that. And so helping them understand that it's about trying to have an equivalent level of risk with this. You don't want to bring additional risk in, higher level risk. You certainly want to help them understand that's a part of the process. But getting in front of them, taking questions, addressing the issues, learning from those, and coming back around. I think all that's really important.
Great. Good advice. Thanks, Nick. I want to leave space for any final questions from the audience, so feel free to drop any other questions or comments in the chat. And then maybe on that last note around, interacting with communities and ensuring that they are understanding of the risks and welcoming infrastructure if it is going to be sited. Are there best practices around making sure that infrastructure, in particular fueling stations, are sited in the appropriate locations? And if so, do you have any best practices around that and making sure that it's not too close to residential areas or other, safety considerations in the siting process?
So a couple things, yeah. So the codes and standards set the ground rules for that. There are best safety practices to consider along the way as well. The other side of it is that we're actually looking to start up on a project that was halted last year on getting information for permitting officials, helping them understand the hazards and how to approach the different things, checklists, guides, case studies, all those sort of things to help them understand. I think can go a long way as well. So um, the key is follow the codes and standards and look beyond those to best safety practices. And when you're dealing with something that's unusual or new, think of drones or ships or whatever it may be that's not currently addressed well by the codes. Think of having an expert group like the safety panel involved because that can help give you and the public assurance that things are being thoughtfully considered.
Great. All right. Well, not seeing any more questions coming through in the chat, but just want to thank you, Nick, for your presentation today and for taking all of our questions. Thanks for being our go-to expert on hydrogen safety and for sharing all of these resources today. We'll follow up with the attendees for the slides and additional resources and links to the trainings and webinars that you mentioned. And if folks have questions for Nick, if you want to get in touch, feel free to reach out. We are also happy to chat with any states who are kind of thinking through this permitting process or working with local governments on a particular project. We're happy to set up a one-on-one call or connect you with other states if that's helpful. So thank you all for attending today. And thank you, Nick, again for your expertise. And we'll see you next time. Thanks,
Thanks,
everyone.
Grace. Thanks, everybody, for having me.
Have a good afternoon. Bye, all.